As built for AutoCAD, Feature Data Tutorial 3, Modeling and Configuration of a Data Structure, Part 3 of 3, Data Capture and Final Conclusions. After this tutorial, you will be able to capture objects and features in the structure tree, link objects and features that relate to each other, add attributes to objects, check and create consistency, define the layout of class labels and your structure tree, and improve your own structure definition. Please watch As Built for AutoCAD Feature Data Tutorial 3, Part 1 and 2 first. For a detailed description of every command, please refer to the user manual. Before we start the project, we will make modifications that give the plan a better and clearer layout. This can be done to each separate class. Go to Definition, Room, Configure. You can change the label's font, font size, layer, and appearance. By choosing your own layer for a label, you can give the layer its own color. There are several options for the label layout. Here is an illustration: label with frame, leader at text, only text, and label compact. For this project, we will keep the original settings. To give the structure a cleaner layout for the data capturing, you can hide classes that are not needed. For example, facility and area only serve as utility classes for inheritance, but objects will not be captured there. Go to the entry classes and select the entry sort classes Show Hide. A dialog with the two fields Hide and Show will appear. You can move the classes from one list to the other with the arrow buttons. Mark the class Facility and click the arrow. Do the same for room, polygon, area, and subarea. You can also change the order of the classes by clicking the up and down arrows. Click OK and you will see that the classes will no longer be displayed in the upper part of the structure. Now, let's add objects. First, we create two rooms. If you watch Tutorial 2, Data Capture, you already know the general procedure. Underneath Office, pick Room. Open the context menu and select Add Room, Inner Point. Click into the room and press Enter. Click again to place the label. The Feature Data Management will create the room object and the respective subareas. We will do the same with the next room, but now select the configuration option in the command line. Disable the enclave recognition Detect Islands if it is selected. Click OK. The room on the left is made of one polygon, while the room on the right is made of two polygons due to the square column. Since island detection is deactivated, the software ignores the column at first. To subsequently insert the island, open the context menu of Room 2, Polygons. Select Add Room Polygon, Inner Point, and click inside the column's boundary. The software automatically recognizes that it's dealing with an island, and the area must be subtracted from the total room area. Under Room 2, expand polygons. See that the column area was added as enclave. Clicking on its entry highlights the boundary in the drawing. To create an inventory, select Inventory, Add Inventory. Select an inventory block, e.g. a table, and confirm with Enter. Pick a point on or close to the inventory to place the label. A new label, Inventory 1, in the corresponding entry appears in the drawing and the structure view. Since inventory has an attribute number with key property, attribute type key, this one is automatically incremented to ensure uniqueness. Now you can create all objects of the class inventory the same way. For demonstration purposes, we will speed up the video. If significant changes are made, we will review them and resume the video speed. Now we are creating three objects of the invisible class inventory type by selecting Add Inventory Type from the context menu. As configured before, this class has no graphic and no label. Therefore, the dialog to change the first attribute description will appear right away due to the setting Check Attribute immediately after creation. Name the three inventory types Office Chair, Chair, and Table. You will get to the next attribute price with the right shift operator button. You can determine the prices as you like or leave them as the default setting 0. The three objects are now similar to a catalog for the available types of inventory in the project. The three workplaces are created the same way. Workplaces do not have a graphic, but they have a label. Place the label of the workplaces close to the desk. No attributes are defined for the class workplace. Now we link the inventory types with the pieces of inventory that exist in the plan. There are two ways to do this. Either you use the so-called forward relation via inventory 10, inventory has type, or the return relation via inventory type 1, inventory has type. In this case, we recommend the return relation because the pieces of inventory have labels in the drawing, making the return relation easier to use. Before we begin, we replace the IDs, inventory type 1, inventory type 2, with the descriptions office chair and table in the object header. Right-click the description attribute and select Show in Header from the context menu. Now the attribute description serves as ID. Now select Table, Inventory has type, link with inventory. The corresponding inventory objects can now either be selected in the structure or you can click the labels in the drawing. Click the labels of the three tables and confirm your selection. To verify the inventory, look at the structure under Table, Inventory has type. The selected inventory object should now be listed here. We will follow the same workflow for the remaining items. Now we link workplaces with inventory. The forward link via Workplace 1, Workplace as Inventory seems most suitable here. The procedure is the same as the one described before. Click the respective inventory labels for each workplace. We will follow the same workflow for the remaining items. In some cases, it is more efficient to create and link an object at the same time instead of creating it first and then linking it. This procedure shall be illustrated by the example Employee uses Workplace. Go to Workplace 1, Employee uses Workplace. Use the context menu entry Add and Link Employee, Add Employee to assign an employee to Workplace 1 and simultaneously add it to the structure. The attribute name is prompted if the respective option has been enabled. For this example, we will type Mrs. Diligent. We will follow the same workflow to add Mr. Smith. Note, should an employee, e.g. Mrs. Diligent, use several workplaces, you do not have to create a new name for the second workplace, but only create the link. Since employees do not have labels and cannot be selected in the graphic, you have to select them in the structure view. It is easier if you choose to display the attribute name in the header, where you can look for Mrs. Diligent instead of Employee 2 in the structure. Select Employee 2, Name, Show in Header. To link Mrs. Diligent to another workplace, open Workplace 3, Employee uses Workplace, link with Employee. Select Mrs. Diligent in the structure view. Left-click the entry and then right-click anywhere in the drawing area. Now we can see Mrs. Diligent under Workplace 3 and Workplace 1. You may wonder when the links between the rooms and facility, base class of workplaces and inventories, are created. The next section shows how this task is done automatically. After various data has been captured, a consistency check should be run. In the Office context menu, select the entry Check, Create Consistency. In the following dialog, one can determine which activities should be run. If a link exists between objects that have been derived from area, e.g. rooms, and other objects that have a label, e.g. inventory, they will be linked with each other if the insertion point of the label lies within the polygon area. If a link exists between two objects that have been derived from the class area, they will be linked with each other when the boundaries of both areas of the objects intersect. If a link exists between two classes, of which one has been derived from area and the other from curve, these will be linked with each other when the outlines of objects intersect. Links with restrictions regarding the number of linked objects can be checked. Helps to detect capturing faults, serves to detect capturing faults, updates all calculation attributes, attribute types, numerical and text calculation attributes. Attributes can be visualized in as-built. If visualizations are defined and enabled, the sequence of display of the hatches can be updated. Click OK. A report will be created after the check. Unclear objects will be made available for editing as references in one or more object collectors. Click OK to close the report. When this step has been completed, the desks and their pieces of inventory will be linked with the respective rooms too. Note: the characteristics, equipment, and cardinality of the links can be adapted in the definition part of the links. For example, links has facility under the context menu entry configure. Concluding considerations. Designing data structures is a challenging and creative process. Important questions to start with are: which inquiries need to be answered using the data structure today and in the future? Our example data structure allows the following queries, e.g. SQL and a database. What is the total value of the workplace used by employee X? In which room can we find an inventory of the type chair? Is there at least one workplace in every room? The following query cannot be answered. How much area, square meters, does workplace Y occupy? Following abstract quality criteria of a structure definition can be named. The structure should be free of redundancy. Every piece of information is contained in the structure only once, thus ambiguity can be avoided. Knowledge that can be derived automatically from other information is not to be captured manually. E.g. the wall surface area of a room can be calculated from room, perimeter times room, height minus opening, area. Level of detail. The draft should come as close as possible to the natural order of things. The classes, links, and attributes receive meaningful names. Simplicity. The draft should be easy to understand and should not contain elements that appear constructed. Flexibility. Future additions, new classes, attributes, and links should be integrated into the current draft without the need to delete classes and links. Inheritance relations should be maintained. Inheritance or link. If a class B is to be understood as specialization of another class A, inheritance is used, e.g. all attributes in class A also exist in class B. Class B can possess additional attributes. A is called a base class of B, e.g. tree is the base class of conifer. The litmus test should always be the examination of the following statement. A B is a special A. A conifer is a special tree. A counterexample. A car is not an engine, therefore a class car should not inherit from engine, even though the possible transfer of attributes, power, fuel, consumption, may suggest it. Instead, there should be a link, car has engine. Attribute or class. An issue S should be modeled a class if one of the following questions is answered with yes. Does a class A sometimes have several entries of S? Does S have its own attributes? Are there specializations of S, means is S a potential base class of another class? Are there links between S and other classes? Direction of a link can be of importance. The direction of a link can be set into any direction when modeling. It often only describes how to read the link's name. Only if a class is linked with itself, e.g. polygon encloses polygon, pay attention to the direction when relating concrete objects. Commands of the feature data clipboard copy and cut have an option that allows the implicit copying of objects of the forward link. Should, for example, the associated inventory type always be created in the new file too when moving inventory to another file, this option can be used. A workplace associated with inventory, however, would remain in the original file since it is related via the return link. When moving a workplace, its inventory and inventory types will be moved too. Should you plan to move objects very often, you should consider the direction of a link according to this aspect. Recommendations. Put a structure definition draft to the test. Take a representative section of the plan and create the structure definition according to your draft. Import the structure into the target application, e.g. a database, CAFM system, and go through the query scenarios, SQL queries, reports. Improve your draft by and by. Only migrate all your plans into the structure when the complete data flow for the plan section works properly. In this tutorial, you learned how to capture objects and features in the structure tree, link objects and features that relate to each other, add attributes to objects, check and create consistency, define the layout of class labels and your structure tree, and improve your own structure definition.